A student travels to college by car. The journey time is normal distribution with a mean of 40 and a standard deviation of 4. And if the journey takes more than 45 minutes, the student is late. Find the probability that the student will be late. Okay. Right, so here is our distribution. This is 40, is it? And this one here is 5. No, 4, thank you. And they're late if it's more than 45. So let's set transform this. That would be 0. And this point here would be 45 minus 40 over 4, which is 1.25. Okay, so if I look in the formula book, I can get this area easily. So that's area of 1.25. But I don't want that area. I want this one. So what should I do here? 1 minus. Okay, so what do I get for that now, please? 0.1. Like this? Okay, let's have a look at the next part now. Ah, very sneaky. Sneaky.
Sneaky.
Anyone know the answer to the second one?
Of course.
What is it?
0.1498.
Is it?
No.
53 minus 40
No. Read carefully.
And between 42 and 44.
Yeah.
Yeah, you just.
Wait, say again?
And it's between 42 and 44.
Now you see, you're thinking along a reasonable line there, but that's if the question actually said 43 minutes. But it says exactly 43 minutes.
So 43.1.
Well, now you're getting closer, yeah. You were thinking, is it Sean now? Come on back in, Sean. You were thinking 43, and you were doing 42 to 44 to get the area for 43. But that's not exactly 43. So what would you need to do? You would need to look at 43 plus a small n and 43 minus a small number. How small should this number be?
0.000001.
That should be like, yeah,
Infinity.
tiny. It should head off to 0. What would this area become if that thickness is heading to 0?
0.
0. You see, this is the thing. The normal distribution can only give you the probability between values. Like, what's the probability that the time will be between 43 and 45 minutes, or 50 and 60 minutes? But it can't tell you exactly 43. Why not? Well, let me give you an example which I remember from university, which I thought was interesting. But we'll just go here for a second. Let's say we have a machine, and this machine makes a random number, okay? And it's a random number, I'll call it x, between 0 and 1. And the way the machine does this is, first it prints out, well, I won't actually include 1, I'll just say less than 1. First it'll print out a random digit, so it'll be 0 point, and then it'll print a digit like 2, and then it'll pick another number like maybe 5, 1, etc. all the way off to infinity. Okay? So suppose I ask you, what is the probability that I get the number a half? Okay, so if I want to get a half, what would the computer need to print out? The first digit? 5. The second digit?
4.
No. 0. Next one? 0. Next one? 0. Etc. Right, let's calculate that probability. What's the probability that I get a 5? How many possibilities are here? 10 if you count 0. So what's the probability I get a 5?
10. 5 over 10.
1 over 10. Did I get a 0?
1 over 10.
Did I get another 0?
1 over 10. 10.
Now what happens if you keep multiplying 1 over 10 forever
They become smaller and smaller.
until it becomes 0? This is the point. You can't get exactly 43 minutes. You could get, you know, maybe you think you have 43 minutes, but you actually have 43 minutes, half a second, 2 milliseconds, 5 microseconds, a nanosecond. You know, you can't get exactly 43. So the probability is 0.
This question is that hard
Yeah.
for 1 mark.
Yeah, well, for one mark they're testing that you understand. It's impossible to get an exact number in this distribution. Now, to be fairly, in real life, if this is a real life calculation, if I said to you, what's the probability the student will arrive in 43 minutes, I would do not quite what you said, but nearly 42.5 to 43.49 or something like that. Because anybody who arrives in this amount of time, we would say, has arrived in 43 minutes. Okay. Now, what is the x? If the probability of the journey time being less than x is 0.04. So there's some number here. That means the area to the left is 0.04. Now, I think because that number is so small, that this, if I mark that as 0, then this would have to be here a negative, because this area is so small. It has to be far to the left. Yeah. So I need to take out my table book and look for a negative z, which equals 0.04. But there's a problem. I can't look up negatives. So I can look for a z so that 1 minus that z is 0.04. Oh, by the way, and I'm calling this here minus z. Okay. So, what z will give me a 96 area? Yeah. 1 point. You're looking. No, you're looking the other way around. You have to find an answer of 0.9600.
0.8315.
0.8315. But remember, z equals x minus mu. What's mu? 40 over sigma. What's sigma? 4. And this should equal 0.8315. Minus. It's minus z. So that means x will equal 40 minus 4 times 0.8315. What is that, please?
The what?
36.674.
That one, that's a good question because it's hard.
No.
What, Lee?
Wait. So that is minus 1.6.
Yeah? Yeah?
No.
You will find it here.
What is the answer?
36.7 minutes.
No, it's 3.
Let's see. Andrew, can you type this in?
No, how do you find it, that value? Why is it 0.8315?
Well, Chrissy told me.
Table.
The table.
96. 0.96.
Yeah, 0.96 is 1.75.
No, that's...
0.96.
think about it.
Yeah.
Is to help you, Lee. You're working backwards. You know the area to begin with, and you're looking for the Z. Not that you know the Z and looking for the area.
No.
Is it okay?
So, if minus one value equals to 0.04, right? So it's 1 minus the positive value equals to 0.04. So
Yeah.
we are looking for whatever value that is equal to 0.96.
And use it.
1.75 is not this 4-digit number. Because we are going backward.
This, if Z equals 0.8315, you don't get an area of 0.9600 on the table?
No.
What?
You get 1.75 to get 0.96. Sorry.
An area of 0.96, that's 9600. Yeah.
0.9599. 1.75.
Chrissy, you told me 0.8315.
You say 96.
No, because you have to look it backward. You have to look it backward.
Ay, caramba.
Okay. Oh,
That's where
I did differently.
Oh, Chrissy.
Sorry.
Alright, what should it be? What should it be then?
1.75.
1.75 minus
Yeah.
equals x minus
But
40
that's what I
over
think
4.
that's first.
No, too late now, Chrissy.
No,
No.
yeah, I agree. No, but that's a 1.75. I'm very also wrong, but.
No, too late. Right, what is it now?
33.
Point, Norton? Yeah, thank you. Okay, so that's wrong.
Now we know
Yes.
it's important.
I don't like red, okay.
Yes.
But I so.
Continue. There's
Yeah,
still one part
the
left.
paper is so tiny.
What's the probability?
I'm like.
What is the probability the student is late for 2 days? So they can either be late, not late, late, not late, late, not late. We actually only care about
Late.
this one. What's the probability that they're late? What was the answer from part 1? What was the answer from part 1? 0.10. Okay, multiplied by 0.1056 equals. What's that now?
Oh, it's the same every day.
Yeah.
You know, I only have one question about
Hang on, one at a time. What's the answer here? 0.0. Okay. Yes, Jerry.
why you only have one question in the possibility?
Oh. Because I only have 3 exams to use. Because they didn't give me any more exams for the new syllabus.
Teacher.
You see, this probability question is new. It was only added maybe 2 years ago. So they've only given me, I only have 3 exams on the new syllabus.
You mean the normative distribution?
Huh?
Remember I did 3 revisions?
Probability.
Oh.
This book, it's just made from 3 past papers.
And the probability itself is added in 2 years ago?
Yeah. It wasn't on the original engineering syllabus. All the probability is new. Yeah. Can I close this?
Yeah.
I can close this?
Yeah.
Sequence.
I hate